Hello viewers, today I am discussing derivation of EMF equation of a transformer. So according to the Faraday's second law, rate of change of flux linkage is directly proportional to induced EMF. So induced EMF in the primary winding can be written as E1 and due to N1 turns in the primary. E1 is equal to minus N1 d phi by dt. So where phi is the instantaneous value. So currently the transformer is alternating nature due to that flux also in alternating in nature. So if I place in place of phi as 5 omega 5 m 5 omega t, that is equal to like this. So this can be written as phi m is a constant I am taking outside, and differentiation of sine omega t. Differentiation of sine omega t becomes omega cos omega t. We know according to the differentiation of sine omega t as omega cos omega t. That will be like this. This can be written as, from this one, cos omega t can be written as sin 90 minus theta. Sin 90 minus theta is nothing but omega t here. This is, can be written as sine of, I'm taking minus common here, this becomes omega t minus 90 degrees. So sine of minus this total is theta. This becomes minus sine omega t minus 90 degrees. So in place of cos omega t, if I substitute minus sine omega t minus 90, this becomes like this. So which means, look at this one, E1 here, flux I have taken as sine omega t, like this. Flux I have taken as sine omega t. Then E2 also sine theta, but induced EMF lags by 90 degrees. 90 degrees, which means the flux will start at 0 degrees. Induced EMF will start at 90 degrees. This is nothing but 90 degrees. 90 degrees nothing but here. Induced EMF will be start at 90 degrees. This is induced EMF is maximum at, this is pi. This is pi. So induced EMF is becomes maximum at 180 degrees. Look at this. So I done normally, because if you draw with the exact measurements, then definitely the induced EMF becomes 180 degrees, maximum at 180 degrees. So actually the induced EMF in the transformer is RMS value, because AC value is represented in terms of RMS value and DC represented in terms of average value. We know that the transformer rating will be like this: 220 by 11 kV, 33 by 11 kV, like this. So which means that this 33 is nothing but RMS value. This 33 is nothing but a RMS value. So we should find the RMS value of induced EMF. So the relationship between RMS value and Emax is, this is ARMS is equal to EM by root 2. So first of all we should find the Emax. Induced EMF at primary becomes maximum when this value become maximum. So according to this figure, this induced EMF is maximum at this point. This is happens at omega t is equal to pi, nothing but 180 degrees. If I substitute here 180 degrees, what will happen? 180 minus this is 90. So sine of 180 minus 90, this becomes 90 degrees. Sine 90, 1. This value will be 1. So finally we will get n1 omega phi m only. Emax is equal to n1 omega phi m only. So we know that omega is equal to 2 pi f. If I substitute to omega is equal to 2 pi f there, we will get 2 pi f n1 phi m. So ARMS is equal to, we know that, EM by root 2. This is nothing but EM. This is nothing but EM. If I substitute this value here, that will be like this: 2, this is by root 2. So this can be written as root 2 pi f n1 phi m. So induced EMF at primary E1 is equal to root 2 pi f nothing but frequency n1 phi m. So root 2 pi value will be 4.44. Root 2 pi value will be 4.44 f n1 phi m. So this is induced EMF at primary. Induced EMF at secondary is 4.44 f n2. E2 is due to n2 and E1 is due to n1. So everything is constant, so this will be cancelled, ff will be cancelled, phi m will be cancelled. Finally we will get e2 by e1 is equal to n2 by n1 is equal to k, which is equal to transformation ratio. Transformation ratio ratio and next turns ratio is equal to n1 by n2, which is equal to e1 by e2, which is equal to 1 by k. This is also called turns ratio. Translation. Generally, the transformer rating will be represented in terms of this value. Transformer rating 33 by kV, 33 by 11, 11 kV, and 132 by 33 kV. This is also, these values are represented in terms of turns ratios. This is transformer ratio. This is used for the calculation purpose. This is used for calculation purpose. So this is the EMF equation